Hi, I'm Paul Ramsey, a database specialist at Google Cloud, where I focus on the intersection of databases and AI. Today, I'm excited to demonstrate how you can build secure, high performance AI agents using Google's Agent Development Kit and the open source MCP Toolbox for databases. We often hear from our customers who want to unlock their real time enterprise data for their Gen AI agents, but they face significant hurdles. Their security teams worry about prompt injection and data exfiltration, while their operations teams worry about agents flooding their database with inefficient queries or unmanaged connections. These are all very valid concerns, and we'll explore ways to mitigate them throughout this video. To illustrate these capabilities, we'll use a fictional financial services organization called Symbol Bank. They're a national retail bank who wants to use AI to reduce fraud and better serve their customers. So imagine I'm a fraud analyst for Symbol Bank, and I have lots of manual tasks I have to complete every day while investigating transactions and accounts that have been flagged for potential fraud. I have to run manual ad hoc queries on multiple databases. I have to analyze that data to identify new patterns of potential fraud, and I have to take manual action to block suspicious accounts. I want to automate this heavy lifting with an AI agent, but I can't just give a stochastic LLM direct, unfettered access to the bank's financial ledger. Instead, I need a strictly governed middle layer with secure networking, least privilege access, and efficient queries and connection pooling. In other words, I have to balance the autonomy of my agent with the stringent security requirements of my organization. To solve for this, I'm using Google's Agent Development Kit as my agent framework, and MCP Toolbox for databases as the secure gateway. For authentication, users access the agent through the Identity Aware Proxy, ensuring only authorized personnel can even load the agent UI. For tool governance, instead of letting the LLM write its own SQL, which can be risky in a production environment, I use MCP Toolbox to expose predefined, parameterized SQL queries as tools. The agent selects the tool, it doesn't write the code. This gives me full control over the queries. Database credentials are stored in Secret Manager, and they're accessed only by the Toolbox host, hosted in Cloud Run, never by the agent itself. All traffic moves over private networking via PSC, PSA, and GPA, keeping data off the public internet. Let's see it in action. So imagine I just got this email from my boss directing me to conduct an urgent investigation into a potential money laundering scheme. And all I have to work with is a few account numbers. In the past, I would have to log into multiple databases, craft queries by hand, trace transactions one by one, and then write up my findings. This process could take several hours. Instead, I'll use my AI agent to do the heavy lifting for me. It already has secure access to my Spanner Graph and AlloyDB databases using Toolbox, so instead of writing queries by hand, I can just tell it what I'm looking for in natural language. Now, as I access the agent, notice that I hit the IAP wall first. Zero trust validation is required before the agent is even instantiated. Now the agent is initialized, and it's retrieved its tool definitions from MCP Toolbox. Note that the agent doesn't know how to connect to the database. It only knows which questions it's allowed to ask Toolbox about. Now, let's investigate the potential money laundering scheme. I have a suspicion about indirect transfers between two accounts. In a traditional workflow, this would be a complex recursive SQL query that would take time to write and to execute. Instead, I'm just going to tell the agent what I want in natural language. So I'm going to ask it, have there been any indirect transfers between account 75 and 199? Under the hood, the agent identifies the Get Indirect Transfers tool. This maps to a Spanner Graph query in MCP Toolbox, specifically optimized for multi-hop traversals just like this. And look at that. It found multiple indirect transfer paths. Let's get more information about the source and destination accounts. Here, the agent's going to orchestrate two different tool calls and synthesize the answer. It looks like neither account is currently blocked. This pattern confirms our suspicions of potential money laundering, and I need to stop the bleeding, and I need to do it quickly. So let's block the destination account. And just like that, without leaving the interface, I've blocked the account that received the illicit funds, and I can continue my investigation. This is one of the many benefits of using real-time data in my agentic flows. I have up to the microsecond visibility, and I can take immediate action. But there's more than one account involved in this scheme, right? Let's find out who owns them. Who owns the intermediary accounts? Here, the agent orchestrated multiple tool calls and gave me information about the owners of the accounts. Let's block those as well. Did you catch that? I didn't list the account numbers. The agent uses conversation history to identify the specific IDs referenced as intermediaries, then executes the block tool for each one. Okay, now let's look into that other account that my manager referenced for a known associate. I didn't see it pop up in the multi-hop transfers, but I should take a closer look at it so I can include it in my report. So let's ask the agent to pull the latest audit events for any accounts that received a transfer from account 11. Here, the agent is going to choose the Get Destination Account Audit Events tool. And interesting, there are two accounts that received transfers from account 11 recently, and one of the accounts is already blocked. Let's get more detail. Let's ask the agent to flag anything that seems suspicious. Okay, so one account is already blocked, the other one is not, and the one that's not has an account password reset, security question updated, and a device unlinked from the account. These could be legitimate actions or they could be suspicious. Here, I'm not seeing anything that's really compelling to block the account. And this is where human judgment is really important. And it's one of the reasons we're using an interactive agent for this use case instead of an autonomous agent. There's really nothing more for me to do here. Okay, there was a lot going on there. And now I need to write up my findings and reply to my boss, letting him know the current status and all of the actions that I've taken so far. Just writing the update is usually a tedious and time consuming process. Instead, I'll just have the agent summarize it for me. Summarize findings and actions taken for a status update to my boss. And there we go. I have a clean summary. The agent parses the session history and generates a structured report. Now let's take a peek behind the curtain and see how this works. If I take a look at the agent.py file, which is running my agent, you'll notice that this isn't a particularly sophisticated agent. It's a standard model with a simple prompt, and the only tools it has at its disposal are the tools loaded from MCP Toolbox. In other words, the intelligence is shifted to the database layer. Those tools are defined in this simple toolbox config file. Notice that I have two sources, Spanner Graph and AlloyDB, and a number of tools, like get account status and block account. Notice that these are simple select statements with parameters. This allows me to have full control over exactly which queries my agent is allowed to run. Toolbox manages the connection pool. So if I have 1,000 agents, they aren't opening 1,000 database connections. They funnel through the toolbox, protecting the database from connection storms. And there you have it. By decoupling the AI reasoning in ADK from the agent execution in MCP Toolbox, we've built an experience that's performant enough for real-time chat and secure enough for even a bank's security team to approve. Reach out to your Google Cloud sales team to learn more about how we can help you build something like this for your own use case. And thanks for watching.